Folks, I'm making this video here to demonstrate how vector addition works in an analytical sense here. So I've made up a short problem here. Imagine we have a vector called vector A. Vector A is 20 units long, makes an angle of 30 degrees with the positive x-axis. I've got a second vector that I call vector B, which is 30 units long at an angle of 290 degrees with a positive x-axis. And what we're going to do is we're going to work on finding the resultant vector, the vector sum of A plus B. So first thing before we do anything else is we're going to draw a picture here. So I'm going to put x, y, draw myself a coordinate system, and the first thing I'm going to do is sketch vector A. So vector A makes an angle of 30 degrees with a positive x-axis. It's 20 units long, so that might look something like this. So here's my vector A, 20 units long, 30 degrees with a positive x-axis. Now, we're going to add to that vector B. Now, vector B is 30 units long at 290 degrees. The important thing to realize is for the vector addition, you need to start B right here at the tip of A. You always add vectors tip to tail. If I were to draw just a quick little coordinate system like right here, right at the tip of A, 290 degrees, right, measured from the positive x-axis would be all the way around and down here into quadrant 4. And vector B is 30 units long. So let's see, 290 would be 270 plus 20 more. So vector B is looking something like this. Vector B is 30 units long. And again, that would be a 20 degree angle right there. Because it's, again, 270 from here all the way to here, right? And then to the negative y-axis. This is 290 degrees, so it'd be 20 more. So there's vector B, 30 units long, at 290 degrees, give or take. Now, I didn't get a ruler out. I'm just kind of eyeballing the angles. Since vector A is 20 units long, I tried to draw vector B, should be 50% longer. I probably should make that a little longer here. I think I'll go ahead and lengthen that vector out just a little bit. Even by eyeball, I can do probably a little better than I did. So there's vector B from here all the way to here. The resultant vector starts at our starting point and ends at our ending point. So the resultant vector looks something like this. So here we got vector A, vector B, the resultant, which is the vector sum of A plus B. All right, now as far as how do we find the resultant? Well, if you've seen some of my previous videos about vectors, vectors can be broken into components. And what we're going to do is we're going to break we're going to break vector A into its x and y components. Then we're going to break vector B into its x and y components. And we'll add them by adding components. So I like to do my vector components in red here. So I'm going to go ahead and, again, just kind of tunnel vision here onto vector A. And what you have to realize is vector A has components that are right and up, or I could draw them up and right. It doesn't really matter which. I'm going to go ahead and draw them right and then up. All right, so this one in red, this is what I would call AX, the X component of vector A. Because it is adjacent to the 30 degree angle, and this makes a right triangle, AX is equal to 20 cosine 30. It's my little shorthand for cosine 30. And I get 17.3 when I work that out. Okay. AY, that's this guy, is opposite the 30 degree angle. AY is equal to 20 sine 30, which is 10. All right, so now this vector A, 20 units long, at a 30 degree angle, we can think of that as 17.3 right and 10 up. All right, vector B. I'm going to go ahead and draw vector B's components. So I could go down and over, or I'm going to go ahead and just go over and down. So there is what I call the X component of B. If I come straight down, there's the Y component of B. I'm going to take a little note here that if this is a 20 degree angle, that makes this one a 70 degree angle because they have to add to 90. So now what you need to do is kind of tunnel vision on this vector. The hypotenuse of this vector is vector b, which is 30 units long. Bx is adjacent to the 70, so that's equal to 30 cosine 70. By is opposite the 70 degrees, so that's equal to 30 sine 70, and I'll talk plus and minus signs here in just a moment. I'm going to go ahead and calculate those values, so give me a moment here. I get 10.3, give or take, for Bx. Oops. Yeah, for Bx, and let's see, By, I need 30 sine 70. I'm using a reverse notation calculator here that I'm not used to. I get 28.2 for By. Now, you'll notice that By points down. Whether you put negative 28.2 now or positive 28.2 doesn't really matter. What does matter is we take the directions into account when we add them. I'm going to go ahead and just leave that 28.2. So my By here is just the magnitude of this length. I'll take the direction into account when I add it. So what we're going to do now is we're going to add x components to get Rx. So again, when looking at this picture, the black vector A and the black vector B have been replaced with a pair of a horizontal on AX and AY and a BX and BY. And these are the four vectors we're now adding. This one, this one, this one, and this one. And we have to add them by direction. So Rx is going to be the sum of these two, AX and BX, which is 17.3 plus 10.3, which is 27.6 units. And then Ry is the sum of these two vectors, AY, BY. But when I say sum, it's the vector sum, which means direction has to be taken into account. So AY here, it's kind of hard to see, but that was AY, the plus 10, because it's up. BY, has a magnitude of 28.2, but because it points down, that's why it gets a minus sign, minus 28.2, and we get negative 18.2. So now what we know is our resultant is 27.6 to the right, 18.2 down. I can go ahead and now draw a little picture for that. I'm going to draw the resultant again. I'm going to draw its components first. So 27.6 to the right, 18.2 down. This is supposed to make a right angle. There's our resultant vector. There's some sort of angle here, theta, that we'll find in a moment. We can find the magnitude of the resultant because the magnitude squared is going to have to equal 27.6 squared plus 18.2 squared. And again, I'm using a reverse notation calculator here, so bear with me. And I get, hopefully I did this right, I got 33 for our resultant. So R I'm going to put as approximately 33 units long. And we can go ahead and find this angle now from right angle trig. The tangent of the angle theta is going to equal 18.2 over 27.6. So hopefully I can get that. And oddly enough, I got 33.4 degrees for theta. And I like to put just DAS here, which if you had me for class, you know what that stands for. Direction as shown, that's 33.4 degrees down from the positive x-axis. You could also give an angle of 180 minus 33.4 in standard notation. So anyway, I hope this video helps illustrate or demonstrate how to add vectors. Have a great day.